Push that rock with some math. Let's talk about differentiating exponential functions. We already have the give birth to the mother rule that says if you take the derivative of e to the x, you just get e to the x. But what if it's not e as the base? Well, we're going to get the rule for when it's not e in this short video. But first, I want to point out something really cool. If you have this, it's true if and only if you have log base b of y is equal to x. And with this, we can use our little properties. The textbooks call this, what I'm about to use, the change of base property, but I call it the cupcake property. What you do is you can write the log as a ratio of logs. So I'm going to have a log up here and a log down here. So a log up here, log down here. The argument is the argument of the numerator, but the base, the base is the argument of the bottom of the denominator. And then you change the base to anything you want. So that's nice. You can make it cupcakes if you like. And this is equivalent to that. Now, the flavor of cupcake that we want is base e. So we want to make it the natural log of y over the natural log of b equals x. And we're going to multiply both sides to get natural log of y is equal to the natural log of b being multiplied by x. And then we're going to say, oh, this is base e, so we're going to use the definition of exponentiation again and logs again, and we're going to say e to this times x is equal to y. Oh, look, this function right here is equivalent to this function. And we're going to use this nifty ability to turn an exponential function into an e function, exponential with e as the base. We're going to use that, obviously, and along with our give birth to the mother rule, to get a general differentiation rule for exponential functions. Won't this be neat? So what we're going to do is we're going to take this function that we'd like to have a general rule for, and we're going to use our new little trick and rewrite it this way. How nice is that? And then we can do a little simple chain rule. We can say f is e to the x, and the derivative of that is e to the x. We could say the function that got put in is a nice little linear function where the slope is the natural log of b times x. See, this is just an m. This is just some number. Natural log of b is a number. So this is like having y equals mx, and of course the derivative of that would be m. So the derivative of this is just the natural log of b. And now we need f prime evaluated at g, so we put g, which is this, in for the x, and we get the natural log of b times x. But we take this and we multiply it by that to get the derivative. And so, because this is the formula, oh, this was supposed to be prime. So sorry, when we took the derivative from here to here, we took, this is the derivative, sorry, left that off. But this is the chain rule formula. So I have e to the natural log of b times x times the natural log of b. But wait a minute, what is this? Yeah, that's just a fancy way to write b to the x. So we have b to the x. Oh, look, there's the mother. Times the natural log of b. That's right. After you give birth, this little thing slides out. It's called the afterbirth or the placenta. And that's why I call this the Placenta Rule for differentiation. And it's a rule for differentiating any exponential function that's not e. Math made simple. Simpson math.